So this is a continuation of Jacob's Algebra, Chapter 9, Lesson 6. We were working on problem 5C, and I had just gotten the problem really written down when the time ran out. So let's look at how this works. This, you can see, is a square of a difference of two terms. So let's multiply it out. We have 4a times 4a. 4 times 4 is 16. A times a is a squared. Then we have 4a times negative 3. 4 times negative 3 is negative 12, and then we have an a. In the bottom left square, we have negative 3 times 4a. Negative 3 times 4 is negative 12, and then we have an a. Bottom right corner, negative 3 times negative 3, that is a positive 9 because negative times negative is positive. And the answer that we get is 16a squared. And then we have two a terms, negative 12a and negative 12a. Those add together to become negative 24a, and then we have a 9. So 4a squared minus, 4a minus 3, quantity squared, is 16a squared minus 24a plus 9. Again, this is number 5, part C, which is just like number 12. Okay, let's look at part D for number 5, and then we're going to move on. Number 5, part D, the problem is 6a plus b times 6a minus b. And again, the problem says to make a diagram to illustrate the expression and use that diagram to write the expression as a polynomial. So for our diagram, we will draw our box, and then we'll put in our grid lines. Okay, now let me put our terms. We have 6a plus b. We have 6a minus b. Top left box is 6a times 6a. 6 times 6 is 36. A times a is a squared. Top right box, 6a times b is 6ab. Bottom left box, 6a times negative b is negative 6ab. And the bottom right box, we have negative b times b is negative b squared. This is a negative here because although the b is squared, it's negative b times a positive b. Negative times positive still leaves you with a negative. So the answer we get here is 36a squared. And then we have a 6ab and a minus 6ab. That's 0. And then our last term is minus b squared. Okay, so the next one to look at is number 6, which is sort of like number 13, but number 13 that I assigned for homework is different enough that I want to do an example that is more like the one that's assigned for homework. So what I'm going to do is just an example I've made up that looks more like it. What if you have square plus triangle times square minus triangle? And I know my squares and triangles are pretty sad. Show what would this look like if we multiplied it out? Well, this can also be done with our box diagram because the box diagram is very versatile and can do lots of things. Okay, so let me put in my grid lines. Okay, so we have box and triangle on one side. We have box and negative triangle on the other side. Box times box is box squared. Box times negative triangle is negative box triangle. Triangle times box is positive box triangle. And then triangle times negative triangle is negative triangle squared. So what would that be if we added it all together? Well, we have box squared. So there we have our box. It's supposed to be a box squared. We have negative box triangle and positive box triangle. That adds up to 0. And then the last thing we have is minus triangle squared. And so that is how this would work. So this is what it's looking for in number 13, is just to complete the pattern to show what the answer would be. The box and the triangle that it uses are just to mean some random term. Doesn't matter what the term is. Okay, so now let's look at number 7. Number 7 is like number 14. It says find the following without making any diagrams. For me, you can always use a diagram, but you do not have to use a diagram unless it says to. So I'm going to show how to work these without a diagram, but you can use a diagram if you want to on the homework. So 7c is 12a plus 1 squared. Now, if you remember the pattern, this is a sum of two terms that is squared. The pattern for that is a plus b squared equals a squared plus 2ab plus b squared. Well, if you look in the work that they gave us, the 12a, that would be our capital A, and the 1 would be our capital B. So if we wanted to just plug it into our form here, our A would be 12a. So we can write 12a squared. The whole thing has to be squared, not just the A, but also the 12. Plus 2 times our A, which is actually 12a, times our B, which is a 1, and then plus B squared. Our B is just this 1 at the end, so that is plus 1 squared. So 12a squared, that is 12 squared times a squared. 12 squared is 144. And then we have a squared. 2 times 12a times 1 is 24a. And then we have just a 1 at the end because 1 squared is 1. Okay, now if you wanted to actually do the work on multiplying this out, then we have 12a plus 1, the whole thing squared. That means we have 12a plus 1 times 12a plus 1. So we can take our first term and multiply it by each of the terms in the second parentheses. 12a times 12a, that is 144a squared. 12a times 1, that's 12a. Now we need to do our second term. 1 times 12a, that's also 12a. 1 times 1, that is 1. You can see that these two terms combine together, and we end up with 144a squared plus 24a plus 1. So it works out the same. You can use the formula they have given you if you would like to. You do not have to work this out the long way. Just be careful when you use the formula that you remember your coefficient gets squared also. Okay, so that was 7c, which is like number 14. So now let's do one more example from number 7. Let's look at 7d. 7d is, whoops, let me try that again. 3b minus 10 quantity squared. Okay, this is a difference of two terms that is squared. Our formula for that, and I'm going to use x and y this time because, it used a b in the problem. If we have x minus y squared, that's going to equal x squared minus 2xy plus y squared. So in this case, our x would be a 3b. So if we square a 3b, let's write that, 3b squared. And then we need to subtract 2 times x times y. So we're going to subtract 2 times our first term, which is 3b, times our second term, which is 10. And then the last thing is our last term squared. Our last term here is a 10, so we're going to say plus 10 squared. 3b squared, that is 3 squared times b squared because the 3 is inside of the parentheses, so the square applies to it also. That is 9b squared. 2 times 3b times 10, that is 60b. And then 10 squared is 100, so plus 100. We can also work this out the long way. 3b minus 10 times 3b minus 10. 3b times 3b is 9b squared. 3b times negative 10 is negative 30b. Negative 10 times 3b is negative 30b. Negative 10 times negative 10 is positive 100 because negative times negative is positive. You can see these middle two terms can be added together, and we have 9b squared, sorry, that's a 9, minus 60b plus 100. So you can see we get the same answer. Okay, so now we're going to move on to number 9 because I had y'all skip number 15. So we are going to move on to number 9, which is like number 16 in the homework. Number 9 says, write each of the following expressions as a polynomial in descending powers of the variable. That means you have to make sure that once you've gotten the answer, you rewrite it from highest power to lowest power. Okay, so we're going to work just a couple of these parts here. Part A, we have 3 plus x squared squared. And I'm going to go ahead and use the formula, which is first term squared plus the double of the product of the terms plus the last term squared. You can use the grid to multiply this out, or you can multiply it out any way that you would like. So when I square the first term, I get 9, and then I need the double of the product of the two terms. So 3 times x squared, and I'm doubling it. And then I need to square our last term. Okay, so 9, that's just 9. 2 times 3 times x squared, that is 6x squared. X squared squared, we multiply our exponents, is x to the 4th. But we're not done yet because we have to write the power, the answer in descending powers, which means we need to start with x to the 4th and then have x to the 2nd and then have our constant. So that is 9a. I'll do just a couple more here. Part B is 3x squared squared. Be careful, remember this square, because the 3 is inside of the parentheses, the square applies to it also. The square on the outside applies to it, not the square on the inside. The square on the inside applies only to the x. So this is like 3 squared times x squared squared. 3 squared is 9. X squared squared is x to the 4th. 9x to the 4th. There's only one term, so we don't have to worry about writing it in descending powers. Okay, one more example. Let's do part D. We have 4y to the 5th plus 1 times 4y to the 5th minus 1. Okay, this you might notice is the sum of two terms multiplied by the difference of two terms. When you have that particular setup, you can take the first term and square it and subtract the square of the second term. The first term is 4y to the 5th. So we're going to square that. And we're going to subtract the last term and square that. 4 squared is 16. Y to the 5th squared is y to the 10th. 1 squared is still just a 1. So 16y to the 10th minus 1, it's already in descending powers. So these were examples from number 9, which is just like number 16 in the homework. Last thing we're going to look at is number 10. Number 10 gives you a worked out problem, and you're supposed to figure out what binomial is being squared to get that answer. So part A, we have x squared plus something plus 16. We have to figure out what would go here in the middle if this is some binomial squared. Well, the rule is if we have a plus b squared, it's going to be a squared plus 2ab plus b squared. Well, this first term has to be our a squared, so a must be x. This last term has to be our b squared, so b must be 4. So that means this middle term must be 2 times x times 4, and that is 8x. Okay, so that is how you work these problems. Number 10, like I said, is just like number 17. You just need to figure out what binomial is being squared so that you can fill in your blank spot. That is all.